Many modern cars surprisingly fail the Moose test. Some spin dangerously, lift two wheels off the ground, even roll over completely. The famous Moose test, made by the Swedish Motor Magazine, tests ability of cars to safely maneuver when something suddenly appears in their path. For example, in Sweden, it's common for moose to jump onto the road, which is why the test is called the Moose test. In traffic, there are many situations when braking alone is not enough to avoid an accident. We need to maneuver to avoid a collision. During these sudden maneuvers, the car mustn't lose control or roll over. The Moose test. Check exactly this ability of cars. Sweden, which pioneered the establishment of Euro NCAP, also leads in this field and tests dozens of cars every year. However, we see that many modern cars fail the test. But why do modern cars fail the Moose test, despite advancements in automotive technology? Let's examine. The Moose test became famous worldwide in 1997, when the Mercedes A-Class shocked the automotive world by failing it. The A-Class had a short wheelbase and high height according to its wheelbase. This dimensions give the car a high center of gravity. When the vehicle was loaded with passengers and luggage, the center of gravity get higher. When a car maneuvers, an outward force effect on it, and this force affects the car from its center of gravity. If center of gravity is high, the greater rolling force effect on the car. You can think of it as a lever principle. Initially, Mercedes denied the problem, but later accepted their fault and recalled thousands of vehicles. Engineers solved the issue by adding electronic stability control, ESP, and revising the suspension system. This problem cost the company $250 million. In recent years, many popular cars have failed the Moose test for similar reasons. For instance, in a 2010 test in the UK, the Citroën Nemo, a commercial vehicle, rolled over due to its short wheelbase and high center of gravity. Similarly, the Toyota Hilux nearly rolled over in test in 2016, repeating its poor performance from the test in 2008. The Hilux is an off-road vehicle, but it should still be able to maneuver safely in traffic. After these results, Toyota engineers visited Sweden to discuss solutions with the test center. 4 months later, Toyota updated the Hilux's ESP system and increased tire pressure by 0.3 bar. The updated vehicle was retested and successfully passed the Moose test. This is the benefit of these tests. They not only test vehicles, but also provide manufacturers with solutions and encourage them to build safer cars. In 2020, the center tested Toyota's SUV. During the test, the driver remarked,
Toyota, the world's largest car manufacturer, has severe problems in the Teknikens Värld Moose test. Want to see, is this car secure? Have they done their homework? Let's test.
The RAV4 spinned and performed poorly because the ESP system didn't sufficiently control the car's movement. ESP is an electronic control system that prevents the car from losing control during sudden steering movements. It detects imbalances between where you want to go and where the car is going, applying brakes to specific wheels to keep the vehicle on its intended path. Mercedes was one of the first manufacturers to use ESP. In 1995, they made a test to show how ESP system makes huge difference. They tested two S-Class cars, one with ESP and one without ESP. In similar to the Moose test, during maneuver the car without ESP lost control, almost drifting. Car with ESP remained stable. This showed how important ESP is. Similarly, in an SUV, a car without ESP can lose control, while one with ESP can remain stable. At high speeds, rolling over without ESP becomes almost inevitable. Thankfully, in 2011 in USA and in 2014 in Europe, it became mandatory for all new cars to be equipped with ESP. The center also demonstrated importance of ESP by testing the Nissan Qashqai, a car similar in size and weight to the Toyota RAV4. At 84 km/h, the Qashqai performed exceptionally well thanks to its advanced ESP system. They then tested the Kia Sorento, which also passed due to its advanced ESP. However, during this process, A member of the center humorously criticized Toyota, saying, "We need to focus more on ESP." Toyota updated the RAV4's ESP software, and in next tests, the car performed better. In 2012, the center tested the Jeep Grand Cherokee. The tires burst during the maneuver. Jeep engineers suspected the test center with changing car software. Therefore, they inspected the car software. However, in 3 repeated tests, the tires burst each time. The test center stated, "We haven't seen such dangerous behavior since the 1997 Mercedes A-Class." They even advised, "Do not buy the Jeep Grand Cherokee for your and your family's safety." I suppose the Jeep engineers must have made the center team so angry. The team tested the Porsche Macan in 2014. During maneuver, the car locked its front wheels and made strange behavior. Even the testing team could not make sense of this behavior. The team is testing the hybrid Volkswagen Passat GT in 2020. At 72 kilometers per hour, the rear of the vehicle spins and it becomes difficult to hold back. Also, Skoda Superb performs similar behavior. According to the test, this result is quite bad. Other vehicles in the same segment are shown as team reference. Even at 76 km per hour speed, Peugeot 508 and Mercedes C-Class perform very good performance. However, in 2015, the hybrid model Mercedes C350 also showed a poor performance, even at 67 km per hour, because these hybrid models are produced on the diesel model platform. With the additional appearance of the battery, its weight also changes. The test center said that this is the reason for bad performance of these models. Ford Mustang Mach test fails in 2021. However, bad ESP is the reason for this situation. One of the most surprising results came from the BMW M4. While the car maneuvered well, the rear of the car spinned. The BMW M4, known for its excellent handling, raised questions about whether good handling guarantees success in the Moose test. Tesla's Model X, however, excelled. Despite being an SUV, its low center of gravity, thanks to its battery placement, enabled it to perform exceptionally well. In fact, the Model X's center of gravity is so low that the vehicle literally refuses to roll over. The all-time champion in the Moose test is the 1999 Citroën Xantia. It passed the test at 85 km per hour, thanks to its computer-controlled active suspension system, which dynamically adjusts the suspension stiffness to keep the car stable during sharp maneuvers. Citroën first introduced this hydraulic suspension system in the Citroën DS in 1955. Unlike traditional suspensions, which place most of the load on the outer wheels during turns, the Xantia's active system balances the load across all wheels, ensuring stability. In conclusion, advanced ESP systems and innovative suspension technologies significantly enhance vehicle safety.